in systems biology, you will ask why is this system the way it is? What are the underpinning mechanistic interactions? Can I understand the design? Can I put the design in relation to evolution? So you'll do the basic biological science of your system. In synthetic biology, you're looking at the same system, but you're asking different questions. You will ask, can I improve on the system? Can I control it in some way? Can I maybe reuse some of the tricks and parts of the, so to speak, the technology that's in the system to make different things, to do new useful things? So it's an engineering view on systems biology.
How does synthesis, the new centre, differ from the Centre for Systems Biology Edinburgh that was here before?
So in a way, we're carrying on doing the same basic science with the same excellent labs and world-leading experts. But what's going to change is that we'll incorporate a new module made of a really energetic and young group of synthetic biology people coming from engineering, bioengineering, some from social sciences. So there are lots of social sciences questions at stake here about intellectual property and also PR, explaining the new technology to the public. And so that team will join us, and they will bring a fresh view, like we explained, on systems biology, and they will bring their own application fields. So that's very exciting. That's one of the new things. And eventually, we'll be building on this. We will connect to this emergent or pre-emergent set of technologies and industry that we expect synthetic biology will bring here in the UK. And the other thing that's changing is we're extending the range of what we're doing by incorporating a lab working on smart chemistry directed at screening huge libraries of chemical compounds with ultra-high throughput at low cost against tissues and systems of interest. So that goes directly into drug discovery, and we have a world-unique technology to do this now. And recently this lab has spun off a startup company where Siemens and other industry actors have taken a part. And so we're really excited to connect to drug discovery in this new way.
How do you see synthesis collaborating with industry in a greater sense, in a wider sense?
So, well, drug discovery is one strong point of contact we already have. We already have some contacts and collaborations on the synthetic biology side. So at the basic level in DNA assembly methods, there's a joint project with Scottish Enterprise where some of the synthetic biology group is involved. But beyond that, synthetic biology will offer lots of new industrial avenues in health, environment, biofuels. We have experts in biofuels, obtained by re-engineering metabolic networks here in the center. So we'll expect that we'll be in a position to increase the array of engagement and contracts and collaborations of all sorts we have with industry based on both sides of the equation. And practically every activity in the center lends itself to such applications. So the big vision is actually that we're kind of stage 2 of the center, and besides the basic science that we'll continue on doing, obviously, and taking on new challenges, extending modeling, extending the kind of system we're looking into, we'll be very keen on pushing what we know and what we've learned into implementing our systems and understanding into application fields. So I'll give you a few examples. So here there's a lab working on, there's a world-leading lab working on plant biology and time tracking mechanisms inside plants. So at a stage where you really truly understand how all these clocks are networked together within a plant, you're in a position to control the network. So you have obvious applications into improving agriculture, food production, by clever technologies mixing synthetic biology and straight systems biology. So we have this kind of perspective. We also have perspectives in biofuels, energy, in biosensors, so that's environment. And so every one of this, potential avenues for application we'll be pursuing. And in so doing, we'll we're looking forward to be completely aboard this, what some people term a new industrial revolution, and to the applications of synthetic biology. There is actually the UK Technology Strategy Board said recently that pre-emergent technology might lead in the coming decade to a £1 billion per year industry in the UK. So it's a very serious global motion of the industry here that we'd like to take part to.
Your future certainly sounds as if it's going to be very busy. Do you see more of these cross-sector collaborations coming to the fore?
Yes, absolutely. I think the key, the way to look at this matrix of interaction that the center should be between various more theoretical modeling, mathematical people and people who are embedded into biology and experiments, is to understand this not as a static relationship between people who are offering solutions, people who are asking questions, but a dynamic system where new questions will come, new solutions or new tools will appear, and we want to keep this interaction matrix alive. And so we'll be seeing new connections, either between people who are already there, or we'll be attracting new faculty and new people bringing new tools so they can have a richer and more efficient and more encompassing dialogue across the disciplines. So yes, absolutely, we see this only increasing.